just know that what I observed, and I think I got a chance to check in with everybody. What you were doing was just what I am hoping. I saw some people who were just figuring out how the stuff works, like getting the thing set up, and like it takes a little bit of practice to be able to use these motion sensors, and that's great. Some people were asking, like thinking about and asking some more high-level questions. One group, for example, was looking at this graph and saying, yeah, well, we kept trying, but no matter how hard we tried, we couldn't get these sharp bends. They couldn't do it. And that actually is impossible. You can't do it. The closest you could come is a little curve here, a little curve here, a little curve here, and a little curve here. And it's kind of fun when you, like, some of you could probably guess why. Some of you maybe don't know, don't have any idea why, but those sorts of observations are really at the heart of what physics is all about. You'll notice things, you'll be like, what in the world? That's where things get fun. When you're trying to explain something like, why can I not make this sharp line right here? What is the deal? What is the problem with that? And we'll see when we start putting some of the math in, we'll see why that's not possible. It's not possible for mathematically, and it's not possible physically either. So what I saw was terrific. So you can just kind of carry that forward. You're all going to be in great shape. The other thing that I wanted to point out, so I'm actually going to start with something that maybe you didn't quite get to. Some of you did, I think. Some of you didn't, but there's this set of questions here. What does the slope look like when you da-da-da-da? What are positive, negative, and zero slopes? What does it mean when the slope is changing? Do you remember at the start of class when I sort of read the graph and I said, well, I'm standing here and then I move to here, and that's what this stuff is all about. This is answering these questions is a way for you to learn how to read a graph. Ideally, you'd be able to say something like, you stand at this position for this amount of time, you walk from this position to this position in this amount of time at this speed, moving away from the sensor at a constant rate. And then you stand still. You can read it once you get enough practice. But I want to go back to something earlier, and I have just enough time to pull this off, because this actually is really kind of cool. So this piece right here says, what does it look like when you walk away from the detector at a constant velocity? Sketch what the x versus t graph looks like. So let's look at that real quick, and you'll see that there's a lot we can say about it. So Allison, can you be my driver again? I'll do a 3, 2, 1. Ready? 3, 2, 1, go. Okay, it capped out. You see that? Like it couldn't tell the distance anymore. But here's what's kind of interesting about this. First of all, the line goes up right while it's moving away from the sensor. Most of you notice that. The other thing is, it's pretty much straight. So one thing that you can potentially, and I'm not saying everybody should have gotten this, and some of you did, but not everybody should have. But one thing that's kind of cool is, once you look at enough of these graphs, you'll learn, oh my gosh, every time it's a straight line, you're moving at a constant speed. What happens when the line is curved is that you're speeding up or slowing down. So that's this piece right here. What does it mean when the line on the graph is curved? Well, the curved line tells you you're speeding up or slowing down. Straight line says you're moving at a constant speed. That's not something that would jump out, I think, to most people. Like if you looked at this position versus time graph right here, with no experience, I wouldn't expect you to look at this and be like, oh, that's constant speed. You might, but I wouldn't expect it. But as we go, that is part of what I want you to start recognizing is, oh yeah, constant speed here, constant speed here. What about perfectly flat lines? What does that mean? You're not moving at all. So with just a little bit of practice with the motion sensor, we now can say, you're not moving, you're not moving, you're not moving. Constant speed away from the sensor, constant speed toward the sensor. That's like some big progress. All right, you all did fantastic today. We won't be turning this in until Tuesday, so no worries about any of that. Have a great on Monday.